Okay, so let's look at section 3.3. So this is about finding the measures of position of the data set. Remember, in the previous sections, we saw, how to find the measures for, the central tendency, right? So, mean, median, mode. Those kind of measures will give you some kind of idea about, you know, the central position of our data set. Now here, we are going to look at the measures of some other positions. Okay, so the first one, which is called the z-score. Let's look at the definition of the z-score. Z-score, or we could call standardized z-score or standard z-score. Standard z-score of the given particular data value, right, which is denoted by little z. Some textbook they use the big Z. So whatever maybe you could use. I will use a little z throughout this course. So the little z is called of the given data value, which is given by, suppose if you have the original data, say which is x, then the z-score of that data value x is simply given by take the data value, subtract the mean of the data set, then divide by the standard deviation of the data set. Okay, so we are going to use this formula to find the z-score or standardized z-score. Right. So this z-score can be applied, right, in either samples or in populations. If it is a sample problem, then your mean, of course, going to be your sample mean. So we use x bar for that sample mean. Then you have to divide, the difference of the original data value and the sample mean. Then you need to divide that by sample standard deviation, little s, right? Or if you have the population data set, then you have to take the data value, subtract the population mean, which is mu. Then you need to divide that by population standard deviation, which is a little sigma, right? So you could use either one. That depends, right? Depends on the problem. Okay, so now let's look at this example. A student scored 85 on English test while the mean score of all the students was 76 in the class and the standard deviation was 4. She also scored 42 on the French test where the class mean was 36 and the standard deviation was 3. Compare the relative position on the two sets. The relative position means nothing but the z-score. So the mean here, the relative position, that is nothing but the z-score. So now we are going to find the z-score for each subject. Then we will compare which one is higher. Okay. So what is the formula? I'm assuming that this was my sample. Okay. So the z-score is given by x minus x bar over little s. So I'm going to use this formula, z-score formula, twice because I have two different subjects. So let us find the z-score for English. So I'm writing z subs of English here. Okay, that is this x means this is your actual data value or actual score. The actual score for the English for that particular person is given 85. So I'm writing x as 85 and subtracting our mean for that particular English class for the class. So the mean was given 76. Then I'm dividing this difference by the standard deviation, which is 4. Okay. So now take your calculator and simplify. So if you simplify, you will get what? 9 over 4, right? So which is 2.25. So that is the z-score for English. So now let us find the z-score for the second subject, which is French. I'm doing the same thing now. Now I'm using this formula. So what is the score she got for the French subject? She got 42, right? Then subtracting the mean for that particular subject, which is 36, then divide by the standard deviation is 3. So this will give you how much? 42 minus 36, of course, 6 over 3, which is 2, right? So now you could compare these two. Which one is higher? Obviously, the English z-score is higher, right? That means the English subject has, the higher relative position than the French. Okay, so let us try in words. Since z-score 4, that is about relative position. So if you are asked to find the relative position, simply find the z-score for the particular problem. Okay, so well, there's a space here I have given for the notes. So remember, if you have z-score positive answer, that means the actual score should be above the mean. That means bigger than the mean of the data set, right? So if you have z-score negative, that means the actual score is below the mean, smaller than the mean of the data set. Okay, so let us write down those 2 points. If z-score is positive, that means the actual score, which is above the mean, of your given data set. If z-score is negative, that means the actual score is below the mean. Okay. So let's okay. So let's look at this problem. I'm leaving this problem. I'm just giving you guys to try this problem. Okay, why don't you try this and let me know if you have any difficulty. So let me explain first. In a recent study, the mean age at which men get married is said to be 26.4, with the standard deviation is 2 years. The mean age at which the women will marry is 23.5 years, with the standard deviation of 2.3. Find the relative position for a man who marries at the age 24 and the woman is married at 22. So basically you need to find the, like earlier we did, you need to find the 2 z-scores and compare which one is higher, right? Okay, only thing is you have to identify the actual score and the mean. Okay, so if you look at the last sentence for this problem, find the relative position for a man who get married at age 24. So this age is going to be the actual age for the man, right? But the mean score for the man. So the men get married, that is going to be 26.4. So this is basically the mean for the man or men get married, and this is the actual. So the standard deviation, find the z-score for the particular person. Then after that, you have to do the same thing for the women and to compare which one is higher and explain in words like I gave last time. Okay. Okay, that is there. Right. So that is about the z-score, right? Now, second thing, this is about the percentiles. The percentiles are positions measures used in educational and health-related fields to indicate the position of an individual in a group. Okay. So remember, percentage means out of 100, right? Suppose if you are given a data set, right? So you are given a data set. So I'm rearranging the data set to the smallest to the largest. Okay, say this is my smallest data value. So first I am rearranging. Say this is my highest data value, maybe any numbers, right? So say this is my largest data value. Okay, so rearrange. Now the percentile will divide the entire data set into 100 equal pieces, equal groups, in another word, right? So if you divide this by like that into, so on, you are dividing up to 100 pieces, right? So this point we call as P1. That means this position, you see now, this position of the data set is my, or the first percentile. Okay, so now this is my second percentile. This value is going to be my second, this data value is going to be my second percentile. And so on, I'm dividing up to 100 pieces, right? So if you do correctly, this is going to be my P99, 99th percentage. So that means what? That means the gap between 2 points is basically 1%, right? So I'm dividing entire data set into 100 pieces, right? P1, P2, P3. So P3, P4, and so on. This is P99, and the last one is, of course, P100, right? Okay. So therefore, if you rearrange in order, you will get such a thing. Okay. So this is called the percentage. Okay. Percentage or percentiles of the given data set. Okay. So now, for example, for this value, right? This value is my 99th percentile, right? So this data value. So this data value is simply nothing but 99th percentile. Basically, the nth percentile will describe the data value. Okay, what does mean by that? That means if you look at this data value, right, 99% of your entire data will be below that particular data value. That is correct, right? Because you see now, this side I have 1%. The remaining 99% of your entire data values are going to be here. Okay, so that is the meaning of percentile. So percentage basically will, make, equal shares with 100 pieces. Okay, so that's a formula, to find the nth percentiles of the given data set. Suppose if you are given a data value, right, by looking at this formula, we could find, the corresponding the nth percentage of that particular data value, right? So the percentile corresponding to the given actual data value X is computed using this formula. So use this formula to find the percentile. How do you find? This is the catch. Suppose if you are given a data value X, right? Rearrange the data set from smallest to the largest and count how many data values are smaller than or below the given data value. So you just count one by one, right? Then after getting that number, remember this is a whole number, right? You are counting number of data values. Then you are adding half or 0.5 with that value. Then divide this number by the total number of data values, then multiply by 100. So this answer may be whole number, maybe decimal, doesn't matter, but this will give you, some kind of idea, how many percentage of the data will fall below those that given data value. Okay, so let's look at this example. Look at that example. The number of traffic violations recorded by a police department for a 10-day period is shown. So you are given 10-day record values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Find the percentile rank of 16. So the percentile rank is nothing but the percentage they are asking. Okay, the which percentile will indicate, the data value of 16. Okay. First, remember, you need to rearrange the data value. So first of all, rearrange the data value from the smallest to the largest. Okay. So let us rearrange. Which one is the smallest one? Yes, 9. The next smallest one, 12. Then 15. Then what is the smallest one? 16. Then 18, 19. I see 20. Then 22 and 24. And the last one is 25. Okay. So remember, I need to have 10 data values. After rearranging, make sure that you covered all the data values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, I have written all 10. Okay. Now remember, percentile will divide the entire data into 100 equal pieces, right? Okay. So now the question is, you need to find the percentile rank, right? In other words, which percentile will give you exactly the data value of 16? You see the data value 16 here, but you need to find how many percentage will contribute smaller than that. That is going to be my answer. Okay, right. So what I'm going to do, I'm simply using the formula. So the percentile formula is given by what? Look at the above formula, this one. So the number of data values below the actual data. Remember, my x is now, I'm looking for the value 16. So this is my x, data value. So how many data values are smaller than 16? Of course, I have 3 of them, 1, 2, 3, right? Therefore, the number of values below 16 is now 3. Then you need to add always 0.5 with your answer. Then divide by number of total data values. Remember, I had 10 of them. So I'm putting 10 here times 100. That's it. So take your calculator and simplify. Okay. So here you will get 35. That means 35th percentile is going to be your percentile rank. Okay. In some book, they write the percentile rank. So percentile rank as percentage, right? Either way, you could write either in percentage or the in words like this. So 35th percentile will be what? The actual data 16. That means what? That means if you look at the number of data values smaller than 16, which contributes 35% of the entire data, it makes sense, right? Because if you look at above the data value 16, how many of them are? 1, 2, 3, 4, 5, 6, almost double than the below, right? Right? So it makes sense because 35 of the data values will be smaller. Sorry, 35% of the data will be here, and the remaining 65% will be covered this side, right? So that makes sense. Okay, so this is the way to find the percentile rank of the given data set. Okay, let's look at the another one. Finding the data value corresponding to the given percentiles. Oh, this is in backwards, right? Here, if you are given a percentile rank, then how do you find the actual data? Remember in previous parts, you are given the actual value in this example. We were able to find the percentile rank, right? Now, this method will explain you in backwards. Suppose if you know the percentile rank, then how do you find the actual data value? Well, we follow this procedure table to do that. First of all, arrange the data sets. So you'll be given the data set, lowest to the highest. Now, the thing is, you need to find, one quantity, we could say one number, right, which is denoted by little c. Okay, the little c is nothing but n times p over 100. Okay, what is little n here? The total number of data values. What is p here? P is the given percentile rank. So this will be given in the problem. Okay, n and p. Simply plugging those two values, find the c. Remember, c could be either whole number or decimal places, right? So based on those two scenarios, now we will decide the step 3, the next step, right? If C is not a whole number, suppose if you get the decimal place for your C answer, round up that to the next whole number, round up to the next whole number, right? Starting at the lowest value, count over to the number that corresponds to the rounded value, right? That means, suppose say if you are getting see some number, say 7, then you have to count to 7th position from the lowest, right? That is going to be your the actual data value. Suppose if C is the whole number, then what do you want to do? If C is a whole number, then use the two data values, which is a C to place and C plus 1 to value of the data value. So these two are going to be the positions of the data value, right? Suppose say C is 4. If C is 4, remember 4 is the whole number. That means what? That means you have to look at two data values after arranging from the lowest to the highest. If C is 4, then look for the data value which is a fourth place and 4 plus 1, fifth place. Take these two data values, fourth data value and the fifth data value. Then find the average of those two, which is going to be your actual data value. Remember, your actual data value may or may not be in your data set, okay? Because we are rounding up, we don't know, right? So let's look at one example. So I'm going to consider the previous data set, whatever we did just now, right? So use the previous data set, use the previous data set, okay? Um, Data set to find, to find, to find the value, to find the value corresponding uh, to the 65th percentile. Okay, so you are given basically the percentile rank, right? So this is nothing but the percentile rank of the the data value. But remember, we don't know the data value, right? Only the percentile rank, right? So look at this percentile rank and identify which actual data correspond to the 65th percentile. Okay, right? So let's look at those the steps we have here. First, you have to rearrange the data. Remember, I'm going to use the data set for this problem. Okay, this is the data set I'm going to use. Okay, so let us write down the rearrange. I'm just simply copying this rearranged data set here. Okay, so if you copy down that, you will get a 9, 12, 15, 16, 18, 19, this is 8, 19, 20, 22, and 24, 25, right? So we had 10 data values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I have rearranged. So what is that next step? Next step is to identify the quantity little c, right? The number little c. The little c is given by what? N times p over 100. Okay, n is the number of data values for the problem. Remember, I have 10 of the data values, so little n is 10. Okay, the given percentile is now 65, therefore p is 65. Plugging these two values into your formula, that is 10 times 65 over 100. So this will give you 6.5, right? 6.5 is a decimal number. So I'm rounding up this number, right? Rounding above, right? To the nearest whole number, which is 7. Okay? That means what? That means the actual data value is nothing but the 7th position or 7th place of the data. So now find the data value, which is the 7th position after rearranging. So 1, 2, 3, 4, 5, 6, 7. So 7th position is 20. So 20. That means my actual data is 20. So 20 is going to be your 65th percentile of the entire data set. So answer is 20. Okay, so that is there. So now let's look at the same example for different percentile rank. Okay, let us find the data value. Find the data value. Okay, corresponding to say 30th percentile. Okay, so I'm going to use the same data set, so I'm not going to write again. So I'm finding it, you see now NP over 100. Okay, remember data set is now having 10, so N is 10, but now P is 30 for this problem, right? So therefore 30 over 100. Okay, this is nice number, 3 whole number, right? So if you get a whole number, the procedure says what? If C is a whole number, then you have to look at two data values, which is C and C plus 1 position, right? My C is now 3. Therefore, I'm going to find, right, my data value. My answer is now going to be what? The data value is nothing but Cth place, third position of your data set plus 3 plus 1, which is the fourth position of your data set, then find the average, add them, then divide by 2. Okay, I'm finding basically these two values, third position and the fourth position of the data values in the data set, then dividing by 2. Okay, remember you need to rearrange. I already have here rearrange, right? So this data set, could you find out the third position? 1, 2, 3. So my third data value is 15 plus my fourth data value is next one, 16th. Then I'm dividing by 2. Okay, so that is put the parenthesis if you want to use the calculator. So this is 30.5. So this is my 30 over 31 over 2. So it's going to be not 30, it is 15.5, right? Let me erase. So it is 15.5. So that means this is my actual data value, which corresponds 30 percentile. Remember, you don't find a 15.5 in your data set. It is okay because we are approximating our answer. Therefore, 15.5 will be somewhere between 15 and 16, right? Right. So that means what? That means 30% of the entire data will cover or below the 15.5 data value. So that's the meaning. Okay. So look at example 3. The frequency distribution for the systolic blood pressure reading of 200 randomly selected college students is shown here. That means there are 200 data values are there in table wise. Construct a percentile graph. Percentile graph is nothing but cumulative graph or jive, right? We already have seen how to draw a jive cumulative frequency curve. Okay, so to draw that, actually the picture is given here. Only thing is you need to complete this table, right? Remember, we all know how to make the cumulative frequency table if you are given a frequency grouped table, which is given here. So the frequency for the first class is 24. Therefore, you need to start with 24. So I'm starting with 24. Keep on adding. Now, how do you find the second cumulative frequency? Well, you need to add 62 with the previous data frequency, which is 24. So just add them. So you get 86. To get the third one, you need to add 86 with the 72, which is 158, and so on, right? The next one, 158 plus 26 is going to be 184. Then 184 plus 12 is 196, and 196 plus 4 is 200. Remember, if you do correctly, the last number should match up with your total frequency. Okay, these are my frequency, cumulative frequency values. So once you know the cumulative frequency values, it is easy to convert that cumulative frequency value into cumulative percentage value. simply convert the answer into percentage. Remember, this cumulative frequency 24, this is out of how many students? 200. But you need to convert into percentage, simply multiply by 100. So find this number. So 24 divided by 200 times 100 will is 12 percentage. Okay. So next one is 86 over 200 times 100. So it's going to be 43 percentage and so on, right? And find all the number. Next one should be 79 and then 92, 98, and the last one is 100. Remember, the last number should be always 100 because we are finding into a percentage answer. So these are all my percentage. So if you draw, you know, the percentile graph, that means so you have to graph the first column as your x and the last column the percentage as your y. So that is why in my y column I have up to 100, and my class boundaries are in my x. And if you plot all the corresponding points, you will get like that. Remember, this is going to be my first point actually from your table, because we already start with 0 always. 89.5 will be 0, and the 104.5 will be 12 percentage, right? And so on. Okay, so this picture will give you kind of idea about the percentile rank. Look at this number 40. What does mean by 40? 40 is the percentile rank for the actual data of somewhere here, right? So this picture, this cumulative percentage curve will give you, kind of, the relationship between the percentile rank and the actual data value. Okay. So suppose if you want to find, say, 70th percentile, in another word, I'm asking you, what is the actual data which corresponds 70th percentile? Simply you find the 70 for, the percentage, then draw a horizontal line and look for the values on the curve, then come to the actual value. Remember, my x values are my actual data values, right? I'm looking for the actual data values by looking at my percentile. So my y is cumulative percentile, percent. In another word, this is a percentile rank. So this will give you kind of idea of your actual data value. So 70th percentile correspond to this data value, right? A little bit smaller than 134.5. So this is another way, to graphically explain the relationship between your actual data value and percentile rank. Okay. Okay. So now let's move to the next one. So there are two more positions about the data set. The one is the next one is quartiles. Remember, in word itself, meaning is there, right? Quartiles will divide the entire data into four pieces. Uh, you know, um, if you are given a data set now, this is the given data set. So I'm dividing into four equal pieces. Okay, 1, 2, 3, 4. Each piece will consist of 25 percentage, right? Then only it will add up to 100 now. Okay. The point where dividing into four equal pieces are denoted by Q1, Q2, and Q3. Okay. So Q stands for quartiles. Take the entire data set, arrange in order from the lowest to the highest, then divide into four equal pieces. Each piece will consist of 25 percentage. That means what? That means the first point here, which is my first quartile, the first fourth piece, in my diagram. The next is going to be my second fourth piece, and third one is going to be my third fourth piece, and so on, right? Therefore, we have to read like Q1 is my first quartile, okay? Q2 is my second quartile, and Q3 stands for my third quartile. If you look at carefully, first quartile is nothing but the 25 percentage of the entire data set will cover under Q1. Therefore, Q1 is nothing but 25 percentage covering. Therefore, this is nothing but 25th percentile, right? So the Q1, you could say in another word, which is 25th percentile in terms of percentile. Okay. Q2, you remember Q2 is exactly the midpoints of the entire data values, right? Therefore, Q2 will consist of first 50 percentage of your entire data set, right? Therefore, this is the 50th percentile. And Q3, of course, Q3 will consist of first 75 percentage, right? Therefore, Q3 is 75th percentile of your entire data set. Okay, that means what? That means if you are asked, for example, if you are asked to find the 50th percentile, this is nothing but to equal and to find Q2, right? Second quadrant. Okay, okay. So let's look at some examples for finding quartiles. Okay. So let's take the same data set and about finding Q1, Q2, Q3. So find Q1 first quartile, Q2 second quartile, and Q3 third quartile for the data set given above. Okay, I'm taking that data set arranged data set earlier we had 20, 22, 24, and 25. So we need to find the three data values. Okay. Okay. Let me change the color for time being. So remember Q2 is nothing but my second quartile, which divide entire data into two equal pieces. Remember, Q2 is nothing but my 50th percentile, right? It will divide the entire data into two equal pieces. I forgot to tell one thing here. Q2 will divide, since Q2 divides the entire data set into two equal pieces, this is nothing but median, right? So look at our previous note. In 3.1, we have looked at, the measures for the central tendency. There you find the median. Median will divide entire data into two equal pieces, right? 50-50. Therefore, Q2 is nothing but median always. Okay? So if you are asked to find Q2, indirectly they are asking you to find the median. Okay? So we already have discussed about the median. So median will divide into two equal pieces. Remember, I have 10 data values, right? Remember, 10 is an even number. Therefore, you will find two middle numbers. So we know how to find the median. Okay. So we already have discussed this. Okay. So that means median will be where? So I'm just finding the middle number of this data set. Remember, you are getting two middle numbers. So median is in between those two numbers, right? Therefore, I'm finding first Q2, that is basically median, right? So finding the average of these two numbers, 18 and 19, find the average, divide by 2. So if you simplify this is going to be 37 over 2, which is 18.5, right? Therefore, median Q2 is 18.5, okay? So this is my Q2. Okay, then how do you find Q1? Remember, Q1 will divide entire data set into what? 4 equal, first, fourth, right? In another word, remember now, you have this side 50 percentage of your data set, and this side also you have 50 percentage, right? You have to have same number of data sets in both sides of the median. So remember, I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There are 5 data values in both sides. It should be same. Now, median will divide, sorry, the Q1, the first quarter will be 25% of your entire data. In another word, half of 50, right? So if you find the median of the first half, right? First half, let me write down somewhere here. Q1, right, is nothing but the median of what? Of simply the first half set. The median of the first half of the sets. Okay, so Q15 is going to be my Q1, right? The midpoint of the first half. In similar way, the midpoint of the second half. So this is my second half of the data set. This is my first half. Okay. Therefore, Q3 is what? The midpoint of your second half. Only look at the second half. So Q3 is nothing but median of my the second half of the data set. Okay. Therefore, the midpoint of my second half is 1, 2, 3, 4, 5. There are midpoints is here. The middle point is 22. So 22 is going to be my Q3. Okay. So if you are asked to find Q1, Q2, Q3, first of all, it is easy to find Q2, the midpoint of the entire data set. Once you have Q2, draw a vertical line to that Q2, then take the first half as one data set and find the midpoint of the first half, which is going to be my Q1. Okay, the midpoint of the second half is going to be my Q3. Therefore, Q1 is 15 and Q3 is 22. Okay, that is my answer. Of course, you could use the calculator to find the quartiles. So I will show you about those things now. So so if you want to find the quartiles, simply go to steps and feed your data values. Let me clear this first. So I'm simply typing the data values. You don't need to arrange, okay? So you could type the raw data. The given data values are now 9, 12, 15, 16, 18, 19, 20, 22, 24, and 25. Okay, so I have entered all the data values here, 10 of them. Okay, right. So now simply go to a step one more time and calc, then one var step, right? Then you will get a bunch of summary values. Now scroll down, scroll down. You see now Q1 is 15, the first quarter. Yes, we got 15. And Q2 is median, 18.5. Yes, we got median as 18.5. And the Q3 is my third quartile, which is 22. Yes, we got 22. So it is very easy, um, when you use the calculators, right? So much I have explained in clear way, in picture how to find the quartile. Okay, under the note, just you could copy down whatever I explained here. So just I wanted to give you about the relationship between the percentiles and the quartiles. So why don't you copy down these three here in the note? This is about the interquartile range. The interquartile range of the data set is nothing but the difference between the third quartile and the first quartile. So the interquartile range of the given data set is simply find the difference between Q3 and Q1. Okay, so that is just an answer. Okay, so let's move to the second one now, deciles. The deciles divide the entire data into 10 equal pieces. So that's what we call this as a deciles, right? We are dividing entire data into 10 equal pieces. Okay, that's very, very obvious now. My first desire is going to be the 10 percentage. That means 10th percentile is going to be my, the first desire, right? So under the note, you could write down D1 is my first desire. That is nothing but P10 in notation wise, right? The 10th percentile. Okay, and so on. So that means D3 means what? D3 is nothing but P30, right? So D3 will divide first 10, first three tens, right? It will consist of 30 percentage of entire data values. Therefore, it is going to be 30%. A data set should be checked for extremely high or extremely low. If you compare your entire data set, there are some cases where you will find one or more data values which are very far from your remaining data values, right? Which is you could consider as extremely low or or higher. Those kind of values, unusual values from your normal data set, which is called the outliers. Okay, so outlier is an extremely high or an extremely low data value when compared with the rest of the data value. Okay, so which is called the outliers. So for example, if you want to look at this, for example, consider the data set. Suppose if I write like that data value, say I have a 9, 11, 12, say 13, 14, and say one is say 50. So if you look at this data value, these are very close data values. Only 50 is very far from the remaining, right? So this could be considered as the outlier, right? That is the example of outlier. But that's a procedure, to find the outlier. So we follow these steps to find the outlier. So procedure for identifying outliers. First of all, if you are given a data set to, identify is there any outlier, first of all, you have to arrange the data set from the lowest to the highest. Then find the interquartile range, right? If you want to find the interquartile range, first of all, you should know Q1 and Q3, right? Because interquartile range is given by Q3 minus Q1. So you should know Q3 and Q1 before finding IQR. So find first Q1 and Q3, first quartile and the third quartile. Once you have IQR, find one number, right, which is given by multiplying 1.5 with IQR. So let me denote that number by little l. So I am writing little l as what? 1.5, right, times IQR. I'm simply multiplying my IQR answer with 1.5. Say that is L, little l. I'm just defining my little l. Now after getting little l answer, subtract this value. Value means little l, right? Subtract a little l from Q1, then add little l with Q3. That means find two numbers, find two numbers, find two numbers. What is that? Uh, Q1 minus L and Q3 plus L. You know now L, right? L is nothing but IQR times 1.5. Now check your data values, data set, and check whether is there any data value, right, which is smaller than Q1 minus L or larger than Q3 plus L. In another word, look for the any data values which are not in this range, which are not in Q1 minus L and the Q3 plus L, right? Look for the data values not in not in this range. If you find any data value or values which are not in this the range, those values are going to be outliers. So I will show you one example, right, to find the outliers. Okay, let's look at this example. Um, Check the following data set for outliers. Check the following data set um, for outliers. Okay. Okay. So this is the given data set. So I'm giving in order, so you don't need to arrange. 13, 15, 18, 22, 15. Okay. So this is the given data set. Okay. So how do you find the IQR? First find the IQR to find the outliers. Okay. So we should know first Q1 and Q3, right? First quartile and the third quartile. So let us find first Q2. How many data values are given here? 1, 2, 3, 4, 5, 6, 7, 8. So my little n is 8. 8 is an even number. Therefore, you will find two middle numbers. So let me strike off both sides. And these are the two middle numbers. Therefore, my Q2 median is between these two, right? Therefore, Q2 is nothing but the average of 13 and 15, which is 28 divided by 2, which is 14. Okay, so this is my Q2. Then where's my Q1? Q1 is nothing but um, Q1 is nothing but the middle point of my first half. This is my first half. So the middle points again. The middle points are now 2 because this side I have 4 data values. Therefore, the middle data values are now 2, these two. Therefore, my Q1 is going to be in between these two, right? That is my Q1. Simply the average of 6 and 12, right? That is 9. That is my Q1. So Q3 is simply the middle point of my median of my second half. Therefore, the middle of these 4 data values is going to be here somewhere. So that is my Q3, right? Simply find the average of 18 and 22. So 18 plus 22 is 40. 40 divided by 2 is 20. So my Q3 is 20. My Q1 is 9. I need these two guys, right, to find IQR. So my IQR is, formula says that Q3 minus Q1. My Q3 is now 20. I got. And my Q1 is 9. If you want, you could use the calculator and enter all the data set and find Q1, Q3. We get 9 and 20 respectively. So 20 minus 9, which is 11. That is my IQR, right? So the procedure says what? Procedure says that after finding IQR, you need to find the quantity, which is little l, right? So I'm finding now little l. Little l is nothing but 1.5 times IQR. So my IQR, I got 11. So simply multiply 1.5 with 11. So 1.5 times 11 will be what? 16.5. This will calculate if you want. Now, what do you want to do after finding little l? You need to look for two numbers, right? Find the two numbers now. Find what are those numbers? Remember, you need to subtract L from Q1 and you need to add L with Q3. Okay, so that means I'm finding these two numbers. So I'm basically finding Q1 minus L. So remember my Q1 was 9, right? I'm subtracting L. L was 16.5. Find this guy. So 9 minus 16.5. So we should be negative 7.5. This side find the value of Q3 plus L. I got Q3 as 20. So 20 plus L, L is again 16.5. Therefore, this quantity is 36.5, right? Okay. Remember, after finding these two numbers, if you have any number, right, beyond this range, beyond the negative 7.5 to 36.5. In another word, if there is any number which is smaller than negative 7.5 or bigger than 36.5, those numbers are now going to be outlined. Do you find such a number? Okay, if you look at my data set, nothing will be smaller than negative 7.5, right? Because in order to get smaller than negative 7.5, you should have the negative numbers. I don't have any negative numbers in my data set. So only you have to look for the numbers which are bigger than 36.5. Do you find any number which is bigger than 36.5? Yes, I find one number, 50, which is bigger than 36.5, right? Therefore, I find yes, one number which is bigger than 36.5. Yes, so that number is going to be now outlier. Therefore, I have only one outlier for this problem, right? So outlier is now only one number, which is 50. Okay. So if you are asked to find outlier, simply don't pick. You follow these steps. You need to find first Q3 and Q1, arrange the data set in order. First find Q1 and Q3, then find the IQR, Q3 minus Q1, then find the little l by multiplying IQR by 1.5. Then you need to find two numbers, right? Q1 minus L and Q3 plus L. And look for your data values. Is there any number out of this range, right? From Q1 minus L to Q3 plus L. Those numbers are going to be outlined. Okay.